Here's a problem about exponential equations to solve. Notice that right here we have 25 and 125 that we need to form to the same basis. So 25 to the power x minus 4 will be 5 to the second instead of 25 to the power x minus 4, and 125 is 5 to the third to the power 2x plus 4. And we have a formula that says a to the power m to the power n equals a to the power mn. So that's my m, that's my n. In this case, that's my m and that's my n. Multiplying m and n, we get 2 multiplied by x minus 4, which is 2x minus 8, equals 5 to the power 3 multiplied by 2x plus 4, which is 6x plus 12. There's another formula that says b to the power m equals b to the power n, implies that m equals n. So we have the same bases and the powers are equal. That implies that 2x minus 8 equals 6x plus 12. Subtracting 2x from both sides, we get minus 8 equals 4x plus 12. Subtracting 12 from both sides, we get 4x equals negative 20. Dividing both sides, let's write it right here. 4x equals negative 20. Divide both sides by 4, we get x equal negative 5. A to the power x minus 1 equals 16 to the power x plus 5. We need to write with the same base. 8 will be 2 to the third, all raised to the power x minus 1, equals, instead of 16 we could write 2 to the power 4, all raised to the power x plus 5. Just like the previous problem, we need to multiply m times n, and that will give me 2 to the power 3x, 3 times x, 3 times minus 1, negative 3, equals 2 to the power 4 times x, 4x, plus 4 times 5, 20. Since we have the same bases, we could say that the exponents will be equal. That implies that 3x minus 3 equals 4x plus 20. And now we could subtract 3x from both sides. That will give me negative 3 equals 1x plus 20. Subtract 20 from both sides. And we get x equals negative 23. And that is our answer. To find the general term, the nth term for the geometric sequence given, the information a1, the first term is 5, the common ratio is 3, and n equals 7, so we need the 7th term. We use the formula a sub n equals a sub 1 times r to the power n minus 1, a7, because n is 7, will equal a sub 1, which is 5, times 3 to the power 7 minus 1 equals 5 multiplied by 3 to the power 6. Using a calculator for 3 to the power 6, we have 5 times 729, and that should equal to 3645. One more problem. To find the general term a sub n equals a sub 1 times r to the power n minus 1, a sub 4, n is 4, equals the first term, which is 2, multiplied by r to the power n minus 1, that's 4 minus 1, equals 2 times r is 5, and 4 minus 1 is 3. That's 2 times 125 equals 250. To find the sum of the geometric series to the nearest 10,000ths, the sum formula equals S sub n equals a sub 1 minus a sub 1 multiplied by r to the power n over 1 minus r. So the sum of the 5 terms will equal to 20 minus 20 multiplied by 1 over 3 to the power 5 over 1 minus 1/3. That is equal to 20 minus 20 multiplied by 1 over 243 over 1 minus 1/3 is 2/3. Moving to the right side, we could simplify this on the calculator, but before we reach the calculator, it's better to simplify our numbers. I could write this as one fraction and make this with the same denominator. So I could say 20 over 1 minus 20 multiplied by 1 over 243 is 20 over 243, all divided by 2/3. And we could also, to reduce steps, add here that we're going to multiply by 243 over 243 to have the same denominator, and that becomes 4860 over 243 minus 20 over 243. Instead of divide, we could change it to multiplication, but we have to take the reciprocal of 2/3, becomes 3 over 2. That becomes 4,860 minus 20 is 4,840 divided by 243 multiplied by 3 over 2. We could divide this by 2, this by 2, that's an even number. This divides by 3, by the way, and gives you 81. So that's one way to do it, to reduce your numbers, or get to the calculator and you will get the answer, which is approximate to 29.8765. That should do it. Since they asked for 10,000th place, that's what we have, 4 digits. Number 6. To find the sum is a sub 1 minus a sub 1 times r to the power n over 1 minus r. The sum of 4 terms, n is 4, will be the first term 340 minus 340 multiplied by 3/4 to the power 4 all over 1 minus 3/4. That will give me 340. I'm going to write this as over 1 minus 340 over 1 multiplied by 81. That's 3 to the 4th, 81. 4 to the 4th is 256. All over 1 minus 3/4 will be 1/4. To have a common denominator, which is 256, we need to multiply this by 256 over 256. And of course, the main division bar will change to multiplication, and we're going to flip 1/4 to be 4 over 1. So what do we have here is multiplying these two, 256 times 340, I have 87,040 over 256 minus 340 times 81, 27540 over 256 all over 1/4. Subtracting these two numbers, I get 59,500 over 256. Instead of dividing by 1/4, we could write instead multiply by 4 over 1. This divides by 4, this divides by 4, or you could just use a calculator. It becomes 59500 over 64, approximate to 929.6875. Nancy deposits 1,500 into a savings account that pays 1.5% annual interest rate compounded every 3 months. Write the equation to present this problem. what will be the balance after 6 years? So we have the formula is A equals the principal multiplied by 1 plus r over n to the power nt. We're starting with 1500. 1 plus the interest rate written as a decimal is 0.015. Since we're doing it every 3 months, that's 4 times a year. So n is 4 to the power 4 multiplied by the number of years, t is number of years, which is 6. Simplifying our numbers, we get 1500, 1 plus 0.015 over 4 to the power 4 times 6 is 24. We could reduce our numbers also more. Dividing 0.015 by 4, we get the following. 0.015 divided by 4, we get 0.00375. So this becomes 1500. 1 point when you add it to the decimal point, 0.00375 to the power 24. Use the calculator to evaluate. So we have 1500 multiplied by 1.00375 raised to the power 24, and of course we need to change this to 2 decimals, 2 digits, so 0.985 becomes 0.99. So the answer is approximate to 1640.99. In money, always we round to 2 digits. Number 8. Angela deposits $1,300 into a savings account that pays 3% annual interest rate compounded every 2 months. Write the equation and what will be the balance after 10 years. Again, we have A equals the principal multiplied by 1 plus r over n to the power nt equals, we're starting with the principal 1,300, 1 plus r as a decimal, 3% as a decimal is 0.03 divided by the number of times. Since if we do it every 2 months in a year, that's going to be 6 times. So n is 6 to the power n, that is 6. Number of years 10 times 10. 1300 and 1 plus, that's going to be 1 point, 0.03 divided by 6. That will give me 0.005. So that should be 0.005 to the power 6 times 10, which is 60. $1,300 multiplied by 1.005 to the power 60, and the answer is 1753.99. 505198. Rounding this number to 2 decimals, it's going to be 1753. It's going to be about 1753.51, or $1,753.51. Caesar invested $400 in an account that grows continuously this time at an annual rate of 3.5%. We need to write the function that represents the situation and what will Caesar's investment be worth after 6 years. For continuous exponential functions, we use the formula A equals b times e to the power rt. This becomes 400, that's the principal, multiplied by e to the power r, 3.5%. As a decimal, it's 0.035 multiplied by t, the number of years, which is 6. So multiplying 0.035 times 6 is equal to 0.21. This will help us finish it and write less when we simplify our numbers. 0.21. Now we type this on the calculator. Let's erase everything. 400 times e to the power 0.21 will be approximate, since we need to round. That's going to be 47. 1 is going to be eliminated. So that's about $493.47. And that should do it for this problem. Sunny had $800 in an account that earns 1.3% annual interest rate compounded continuously. We need to write the equation just like the previous problem. And how much will his account be worth in 7 years? Again, we have A equals B times e to the RT equals $800. That's my investment, times e to the power, the interest rate 1.3 as a decimal will be 0.013. We need to multiply that by 7 years. T is 7 years. Again, simplifying our numbers using a calculator, we could say 0.013 times 7 equals 0.091. That's 800 multiplied by e to the power 0.091. Now we finish it times e to the power 0.091, approximate to 876.22, since we need to round to 2 digits. That should be 22 cents. And that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.